Hello, my name is Mohammad Irfan bin Abu Razali, and this is my project for the Alpine assignment for 2021. The components needed for the implementation of this smart container is an ESP8266 Wi-Fi enabled board, an IR sensor, a DHT11 temperature and humidity sensor, as well as a micro servo motor SG90, all powered by a 10,000 milliamp hour power bank. As for the software, the Blynk application is used to communicate and control the smart container with its sensors to visualize the data captured, and as well as control the servo motor that was shown before. To demonstrate how the smart container would function, first we must make sure that the reset button is pressed once and close the device. And you hear that once the device is connected, the application must also be run in order to see both of the devices communicating with each other by Wi-Fi communication. So once both the application and the smart container is both connected, you would see that there's a status shown in the application where it says that it's online. And what we can do now, you can notice that the actual box is locked in place by the servo. And so if we tap on unlock, you will hear a sound where now that the servo motor is running to a position where it allows the box to open. And once we open it up, we can see that a notification is given to the application. This notification will keep on running every 5 seconds to notify the user that the container is open and it must be closed immediately. And so to see the servo motor in action, we can actually just press, when we press the lock button, you can see that the servo motor turns to the locked position, as well as when we unlock it, it will go to the unlocked position. As for the how the smart container knows when the lid is closed or open, a simple solution was done where the IR sensor basically detects if there is something in front of it. So if it detects if there's something in front of it, it basically detects that it's closed, and if the connection is no longer there, if there's nothing in front of the IR sensor, it would immediately notify the application that the lid is open. So to show this again, I'll just open the box, and you see that it notifies the user that the container is open. So this lid is what interfaces with the IR sensor. If the connection is broken, again, it will detect that it's open. To visualize data visualization working, we will be using a hairdryer to basically increase the temperature within the smart container, to show that the temperature will be increasing over here. So right now it's 28.1, and if we just turn on the hairdryer and hairdry the unit, so as you can see, now the temperature is already 39.9, and the humidity also changed. So an extra feature is that once the temperature is above 40 degrees Celsius, it would show that the temperature is too high, and it shows the actual temperature of the smart container. And so now to see what data has been collected just now by heating the environment around the smart container, we can see an expanded view. and this is live feed from the smart container to the Blynk application. So if you scroll back, we can see just now that there was a huge spike of heat when we dried it, as well as when the humidity also dropped when the temperature got too high. So that shows a correlation between the temperature and humidity within the smart container itself. And you may have noticed that there are these bars. So these bars are indicating when the actual box is in the open position. So this could be used by the user to see, okay, so during this time the box was open. To see it in action live, you can just open it up, and you can see that a new bar has just popped up, and this would be continuously shown every 5 seconds. So you can see there's another bar produced from the smart container that was in the open position. Another data visualization and collection method was also done with the platform of ThinkSpeak, where this information can be gathered remotely from anywhere using the platform website that's given by ThinkSpeak. So as you can see, we have the temperature graph shown, where just now around 256 there was a huge spike in the temperature where we hair dried the actual smart container itself. So this data can be used for to monitor how the contents of whatever contents inside the smart container could be harmed by these treacherous conditions. As we can see also that there was a steep decline in the humidity inside the box itself. So that has been my video presentation of the smart container. So my name is Muhammad Irfan bin Ambarzali, TP number TP051882. Thank you.